All right, guys, let's go ahead and take a look at this second example. It says, you're interested in the amount of Apple iPad sales over the long term of a business. You sample the sales over the course of February, which is 18 days, and find the average sales per day to be 14.3 with a standard deviation of 2.3 units per day. Create a 95% confidence interval for the population average sales per day. There's a lot going on with this one, but the first thing we're going to try to figure out is which one are we dealing with? Well, first off, hopefully you can realize that this one right here does mention a standard deviation, but nowhere in front of that standard deviation does it say population standard deviation. So this means that our population standard deviation is unknown. That means we are going to be using a t-distribution, a t-chart. So let's go ahead and start writing down what we do know. First things first, we know our confidence level, our C, is going to be equal to 95%, which is essentially 0.95. Now we will be using that to determine our T confidence a little bit later, but for now, let's go ahead and leave it. All right, next up, we need to figure out everything else. So we know that our average, or our mu, or our x bar is going to be 14.3. So let's go ahead and write out our x bar. X bar is equal to 14.3. We also know that we have a sample standard deviation. So our sample standard deviation is going to be denoted with the letter S, and that is going to be equal to 2.3. Okay, and it looks like our sample size, also known as N, is going to be equal to 28, since there are 28 days in February, unless it's a leap year, but this is clearly not because it says 28 days. And from our N, we can determine our degrees of freedom, also known as dF, and that is going to be equal to 1 minus our N, in other words, 27. Now, in order to find our T confidence, we are going to need to find out where our degrees of freedom 27 meets up with our confidence level of 0.95. I did find that earlier, so I'm going to take a look. And that is going to be 2.052. Now remember, you can find your T confidence by looking in your T chart, which you should have handy, or hopefully you do. You're going to see our T confidence is going to be equal to 2.052. All right, in addition to our T confidence, we also need to know our standard error. So our standard error is usually denoted with our sigma of x bar. For a T confidence, we're actually going to use S of x bar because we're not using sigma for our standard deviation. So let's go ahead and do a sigma of x bar is equal to, remember our standard error is going to be standard deviation divided by the square root of n. So let's go ahead and make a fraction. Standard deviation is going to be S divided by the square root of n. And this is getting really small, so let's actually make everything just nice and big for you all. There we go. All right, now remember, standard deviation over square root n, well, we have both of those, so we can go ahead and set that up right now, which is going to be standard deviation 2.3 divided by the square root of n. Square root of n is square root of 28. And we can find that pretty easily. The square root of 28 is 5.29 approximately. So 2.3 divided by 5.29 And 2.3 divided by 5.29 is going to be equal to about 0.4347. Let's call it about 0.434. All right, last thing we got to do as far as finding our variables is to find our margin of error, also known as E. And that's going to be equal to our T confidence and our standard error multiplied by each other. So we're going to do our T confidence times standard error. And that is going to be equal to 2.052 times 0.434 and 0.434 times 2.052 gives approximately 0.89. Last thing we have to do is both add and subtract this number from our X bar. So let's do 14.3 plus 0.89. We get just about 15.19. We're going to do the same thing, but instead we're going to subtract and 14.3 minus 0.89 is going to give us 13.41. All right, we have a range of values now. We have our interval, our confidence interval. So we can go ahead and set this up and answer the question. Quote, we can be 95% confident that the population average of all iPad sales will fall between 13.41 and 15.19 per day. And again, remember your confidence, or C, goes right here. Your subject matter go right around here. And I could have also said per day before here. And of course, your low value first, your high value second, and you're done. All right, guys, thanks for watching.